Hello everybody, this is Naveen Sinha again. Today I'm going to talk my project in much more detail. So what I'm doing is I'm analyzing New York's rush hour by analyzing different types of data set which I collected from different sources, and which is I get a data set of green cab for the month of 2015, which contains all the trips the green cab did for that month. Then I take data, geolocation data, which is essentially the latitude, longitude data mapped to a zip code. Then I also take weather data for a zip code, and then for reference I took the zip code where Empire State Building is, and then I'm merging all these three data sets to create a much smaller data set, which I use it for my machine learning. Just to get a more view on this data set, I'm going to quickly flash another document where I have captured the details on this data set here, which is much more descriptive. So if you see it, this is what I have: the New York green taxi trip data, which has many fields. A field of interest for me is the individual trip, at what point it originated, and what is the total amount that trip costed. And okay, so this is what I get. I trim it down, as I said, by taking only data set during that duration, 6 AM EST to 10 AM EST during the rush hour. Then I get this geo data, which is a zip code to latitude longitude mapping with the name of the area, county, and all. Then I also have the data which I collected from the weather website. I think it was Wonderground, yeah, for the month of April 2015. And I have different fields here. If you see, I have temperature, dew point, visibility, precipitation, and the weather conditions, wind speed, and all that. Now what I do is, flipping back to my this one, I collect this data, merge it together, and then I create a much smaller data set. Then I use this, I create this data using Apache Flink batch, which I thought to explore, put an extra effort to explore that. And then I run Apache Flink machine learning algorithms, mainly multiple regression and gradient descent, to train my model. And then once it is trained, I run predictions. Talking about technology, this is same Apache Flink batch, Apache Flink machine learning. The programming is in Scala. Talking about Apache Flink, let's quickly talk about Apache Flink. So Apache Flink is a new offering from Apache Foundation, which is very much similar to Spark, but it has some differences, and it is giving tough competition to Spark, or at least in future it's going to give tough competition to Spark. It is built with the same set of use cases in mind, but it provides something more advanced, or more interesting. In fact, Spark doesn't provide that, which is a data stream API. So the major difference between Spark and Flink is made from streaming, starting from streaming, and it is built on streaming APIs as streaming capabilities, and it implements batch as a special case of streaming. In case of Spark, it is the other way. Spark essentially is a batch engine wherein you submit a job, and it provides you support for data streaming, but it is essentially internally under the hoods. It is running each of those streaming as macro batches. Talking about the Flink stack, how it works, very much similar to Spark or any other, say Hadoop or any other product. Nothing special about it. Okay, so this is about Apache Flink batch on streaming. This is what I briefly touched upon. Now let's talk about Apache Flink machine learning. So the main focus of my project is to really explore the machine learning capabilities of Apache Flink. So what I do here is I'm using supervised learning, and then I have taken one of the machine learning API, and I have explored in great detail about it. So these are the capabilities provided related to machine learning by Flink. This is the summary of my project, so which I talked about. So which essentially is I get the data from different sources. I create my own data set for my machine learning algorithm. Okay, so I'm going to talk about that in learning. So what I do is about machine learning, what all features which I use. So after creating my data set for my machine learning, I use Apache Flink ML machine learning API to fit my training data set, which I created by merging all those three data sets. And then I use multiple regression algorithm. I use feature scaling using standard scaler provided by Apache Flink. I also tried to use polynomial transformation. This essentially is used when you want to take care of higher order terms in your regression, or when you think there are some interaction between different terms. I use binary encoding for categorical variables. In my data set related to weather, I have some categorical variables which are not really represented as numbers, but more like string, like the weather condition can be clear, overcast, and all that. Okay, so issues, benefits, pros and cons. I'm going to talk about this later. So let's go back to code. Let's see some code. Okay, so here is my two important files. The first file is my data preparation file, and I'm going to just glance through it very fast. So I have execution environment of Flink. I load the files here, and then I trim off some of the data elements which I don't want, mainly the headers. I essentially run a series of map and reduce to really group my data together. So in my case, what I'm doing is I'm taking individual trip data, then based on a range of latitude and longitude, I'm summing it up to find out what is the total amount of money spent by New Yorkers or people staying in New York State to spend money. I mean, what is the total amount they spent on green cab taxi? So my analysis is based on the green cab taxi, but essentially it shows you that how really we can analyze different data sets and then run predictions or extract information, and how we utilize that information to run different kinds of predictions and hypotheses. Okay, so this is what I do, and then apart from doing reduce, I'm also doing multiple joins, because I have to really merge data from different data sources. And at the end, once I'm done with all that, what I'm doing is I am writing that data to a file, and that file is essentially the training data set which I use for my machine learning algorithm. I'm going to talk a little more on machine learning algorithm, because that is the main focus of my project. So again, I have kept I've been exploring this. I have kept the code very simple so that I focus on really the capability, not really on the minor things like making it parameterized and all that. You might see some errors in the code, but these are not errors. These are mainly for some reason my Eclipse is behaving weird. I think this is related to the Scala version mismatch. So it shows me as red, but it allows me to run the code and really run my code. I mean, I don't get any problems running my code. So, okay, so let's talk about in more detail. So here, if you see it, I'm reading my data. I'm reading my data and then really cleaning it up if there is some required for some special character or anything. Then I'm again reading. Okay, so then I'm making a vector data. So I'm using a standard scaler here, if you see it here. So the standard scaler really expects a vector and a vector containing all your features, the data for all your features. And using that vectors or a data set of vectors, it really runs train itself, I should say. I mean, it uses a API called FET, which essentially is the standard scaler is training itself with your feature vector. And why we need scaling? I mean, we need scaling because in my data I had multiple data elements or features which were of very different scales. Some were in huge numbers and the others were in some fractions. Okay, so standard scaler essentially takes all your data elements, finds out the mean and the standard deviation of it, and then really identifies a scaling parameter and scales your data elements. So once I create the scaler, what I'm doing is I'm transforming my trained data. Okay, so which I train data. Okay, I will go switch back a little. So this is a program, this is a function where I'm reading all the features. I have some normal features which are the numeric features, and then I have some categorical features. So using these two features and also my label point, which is I think we all know what is label point. What I am doing is I'm creating a label vector. So this is slightly different. I mean, it is concepts are similar, but in Spark we call it labeled point. Here we call it labeled vector. So I create the labeled vector, and then as we saw, I have a scalar. So I pass on that pass that scalar my training data, and it really gives me a scaled train data. Or it is my label points scaled as per the standard deviation and the mean of my feature range. Okay. Another thing which I really tried to use experiment with is the polynomial features, which is really an advanced concept in regression. So what I do is I take if you have correlation, or if you have higher order terms, this is what you do. Okay, so I train my data, and then this is my multiple regression algorithm. I put different parameters, and then I train my data. This phase nothing but train my data on it, and then after doing that, these are the weights. I mean, it calculates the weights. I'm also calculating the standard residual, which I'm printing, and I'm running my predictions. So I run my predictions by call predict method on that. So this is on a very high level my code is. I'm also exploring a gradient descent algorithm, which I'm using to further optimize my parameters or my betas of my regression. Okay, so this is what it is. So let's look into how I run it. So this is my first program which I run it to prepare my data. So this will run for multiple minutes, so let it run. So we'll see it, and then okay, so while it is running, let's try to cover some more. let's try to cover some more things. Okay, let's talk about this one. So issues, benefits, pros and cons. Flink, as I'm saying, it's really powerful, but yeah, as it is a new tool, I mean, these are the pros and cons. I mean, of Flink. It has many pros, which is good, but cons, new in the market, new, very limited support on internet, and one major problem which I faced was it did not have support for Python, so I had to write my code on Scala. Okay, now this is an important slide, so let's talk about it. So lessons learned. So before I do that, to save some time, I'm going to see if it is running. Yes, it is running. This runs a long time to really do that. So what I've done is, while it is running, I can also really have a data set created by this process, so I can run my second one as well, my machine learning, just to save time. So I kick off my machine learning also. Now this is not really going to get the data from this set of my data preparation step on the left hand side, but it is going to take from a different set. Okay, so I'm getting some error. Let me see. Okay, some error. I'll have to pause my video so to save some time and not really go beyond the limit. Okay, so coming back to it, I got some error when I tried to run my machine learning while my data preparation Flink batch process was running. This, if you see it, it is mainly because Flink manager didn't have resources. So now that my other process is closed and has ended, I should be able to run it now. So I kick off this process. While it is running, let's go back and complete the slide on pros and cons, lessons learned. Some of the important things which I would like to highlight. Data analysis, I mean any analysis based on big data, preparation of data really takes a lot of time, which essentially is cleansing the data, getting the data in the right format, dropping unwanted data and all that. And then in my case, I had to really merge this data with different other data sources, so it took me really a long time. The other thing is these tools are new. Apache Flink is new, so it has a little longer learning curve with limited support. Its machine learning is robust, and then it provides multiple algorithms out of the box, which is good. But again, the support and examples on internet is really available, is less available. Now let's talk about my machine learning outcome. My machine learning outcome did not really do a great job in predicting the total money spent based on weather conditions and during rush hours and the weekdays, the days of the week. It didn't really do a great job. This may be mainly because the training data set was very limited to 1 month, which was month of April, and it didn't really, the weather conditions were almost static. It didn't really change a lot. The temperature was in a good range. I think if I look at the data set, it just rained one single day. So it was so as there was no much of difference in the data set, like there was no storm, there was no snow, there was no much of rain, so many of my features did not really become significant in my model. Okay, so that's why my prediction went really bad. But okay, so that was really the statistics part of it. But my exercise really showed, I mean, I really learned a lot about from this exercise. This exercise really showed that how to create data from scratch and then feed it into machine learning algorithm and run different types of predictions. It highlights the technical steps and challenges involved in such kind of analysis. So it had been a great learning experience, and then I'm sure that I'm going to analyze the same data set over and over again to explore multiple information or interesting facts from the New York Cab data. Now let's switch back and see if my job finished. Yes, my machine learning job finished. Let's look at some of the data before I really drop off. Well, so these are the data sets which I'm predicting. So this is the first data set is my prep data, is the one which is created by my Flink batch. Let's see it. Prep data. Okay, so this is, if you see, this is my merge data. Let's see the other data, which is my prediction. So prediction is so head minus 20 prediction. So this is my prediction. Now if I see it, no, I mean if you see it, I'm predicting the whole data. I'm dumping the whole data set object, and then this is the dense vector, and the final number is the prediction. I didn't really do the model is not really doing a great job, but yeah, I mean so this is how I run it. Unfortunately, I did not get time to create any visualization, so this is all I have. Okay, so this is all I have. Thank you. Thanks everyone. Then I will leave it to the first slide.